On January 28, 1986, the Challenger Space Shuttle exploded 73 seconds after liftoff, killing all 7 astronauts on board. The disaster was caused due to the fact that a tiny rubber part of the spacecraft, called the O-ring, could only work properly above 53 degrees Fahrenheit. That winter morning, the temperature was 36 degrees. Despite engineers' warnings during a pre-launch teleconference, management chose to proceed with the launch, finding data inconclusive and unable to prove that launching was unsafe. The rest is history. So, we want to examine how organizations can arrive at correct decisions, which is our dependent variable. Of course, the definition of a correct decision varies depending on the circumstances of each case. In the Challenger disaster, the correct decision would have been to refrain from launching the spacecraft. Let's make a model and investigate factors influencing the adoption of correct decisions at organizational level. Based on our case, the research question that we have identified is, how can organizations make correct decisions having learned from failed decisions in the past? This links us to the first and fourth themes that we have discussed in class, which are judgment and decision-making and learning from errors. We have defined our dependent variable as correct decision at organizational level. According to Brooks et al., an organization-level decision is information elaboration by members of a team working together to exchange, discuss, and integrate information. A correct decision is one that aligns with the desired outcome or goal based on the available information and circumstances at the time of making the decision. We chose this dependent variable as the outcome we want organizations to achieve based on our case and research questions. The first independent variable, which we also had in our initial model, is effective communication. According to Yaziki, effective communication can be described as a combination of how well information is delivered, accessed, shared, and used. Effective communication has a positive relationship with correct decision at organizational level. According to Russell, when communication is not adequate, organizations function as individuals rather than members of organizations, indicating the positive relationship between our IV and DV. Hence, because effective communication must be present to achieve correct decisions within organizations, we have decided to include it in our model. We have also added groupthink to our model as a moderator which influences the relationship between effective communication and the dependent variable. According to Banabu, groupthink is a pattern of thought characterized by self-deception, forced manufacture of consent, and conformity to group values and ethics. Groupthink has a negative influence on the relationship between our IV, effective communication, and the DV. As Ahmad et al. Note, groupthink leads to a lower number of explored solutions in group decision-making, and consequently to lower decision quality. The second independent variable that we selected is psychological safety, which is a shared belief held by members of a team that the team is safe for interpersonal risk-taking. Psychological safety leads to correct decisions at organizational level via the mediator learning from errors. An important reason why we chose psychological safety as an IV is the abundance of literature which supports the notion that psychological safety must be present for organizations to learn from their errors. As noted by Edmondson, team psychological safety diminishes anxiety surrounding potential reactions to actions that may evoke shame or threat, thereby fostering a conducive environment for learning behaviors within work teams. For example, team members may hesitate to voice concerns or highlight errors that could inform future improvements due to apprehensions about being perceived as incompetent, consequently undermining the team's effectiveness. Conversely, individuals are more likely to speak up when they feel respected by their peers and confident that mistakes will not be held against them. The mediator learning from errors, according to Zhao, is a process through which individuals reflect on errors they made, locate the root causes of the errors, develop knowledge about the relationships between actions and outcomes, and the effects of these relationships on the work environment. They then use this knowledge to modify or improve their behavior or decision-making. From this perspective, learning from errors is an effortful activity. It involves purposeful reflection, analysis of errors, and application of new knowledge into decisions or actions. The reason why we have chosen this mediator is because it is related to the research question and is important to explain the case. We have mentioned that there are many articles supporting the relationship between psychological safety and the mediator learning from errors, and we have decided to dig deeper and evaluate this relationship using 2 more articles. The first is an article by Ye et al., which indicates a clear empirical relationship between psychological safety and learning from errors. It focuses on psychological safety being an essential mediator between inclusive leadership and employees learning from errors within their organization. It has been found that employees' psychological safety was positively and significantly related to employees learning from errors based on an R value of 0.35 with a p-value of less than 0.01. However, it's important to note that psychological safety was considered a mediator in this study, meaning inclusive leadership must also be present for learning from errors to occur. Our model does not include inclusive leadership as an IV, which lowers the validity of our model. The second article that we have found is by Carmelli and Gattel, which also shows a strong positive relationship between psychological safety and learning from failures. It has been mentioned that learning from failures was positively and significantly related to both high-quality relationships and psychological safety, with an R value of 0.60 and a p-value of less than 0.001, again indicating a strong relationship. Once again, psychological safety is found to be a mediator in this study. Limitations of both studies are that they were conducted in specific areas, which may limit the generalizability of the findings, and they use self-reports, which are subjective measures, to assess the variables. Turning now to the characteristics of the context, we find that our model is high stake and moderate valid. It is high stake because outcomes based on this model have significant implications in cases like ours. Correct or wrong decisions can sometimes be a matter of life or death. In the context of the Challenger Space Shuttle Disaster, an incorrect decision took the lives of 7 people and impacted many others around them. It is moderate valid because if all variables having a positive relationship with our DV are present, it is quite probable that the DV will materialize. In other words, with effective communication, psychological safety, learning from errors present, and groupthink absent, it is likely that organizations will make correct decisions. Our model is, therefore, not low valid. However, decision-making in organizations is complex, and there are other relevant factors not reflected in the model that may affect decision-making, preventing us from characterizing our model as high valid. Such factors are, for instance, information availability or cognitive biases other than groupthink, which may affect the quality of a decision made at an organizational level. We built our model based on the Challenger Space Shuttle case in order to investigate how organizations like NASA can make correct decisions, having learned from errors made in the past. Therefore, the context of our case, that is, the environment in which the situation we assess is taking place, has the following characteristics. Our model is built in the context of organizational decision-making. In other words, we are assessing decisions at the organizational level. It is an environment where people from different backgrounds are working together, where high-stake decisions are being involved, and where the subject matter of decision-making is not simple. Though in our context, decisions can and should be based on science, there is inevitably uncertainty involved, for instance, because data can be inconclusive. In our context, the environment is largely hierarchical, with managers having a greater say over engineers. Our model will, therefore, work in contexts with similar characteristics. For instance, this model would be helpful to understand organizational decision-making in large pharmaceutical companies, where complex R&D decisions are involved. In contrast, our model will not be applicable in contexts concerning individual decision-making, as our variables are not applicable when the individual, rather than the organization, is concerned. Let us now go back to our model. Since our model could only have a maximum of 5 variables, we had to make a choice and exclude variables that we would potentially have included had there been no such restriction. Some variables we considered as being relevant in the context of our case, but ultimately did not include in our model, are information availability and error management training. Informational availability is important for making correct decisions. We opted against including it in our model because within the context of our case, the necessary information had already been accessible to those tasked with making the decision to proceed with the launch. The primary issue arose from the ineffective communication of this information among various stakeholders, resulting in discrepancies in how managers and engineers perceive the evidence, or the absence of evidence, and consequently, a lack of shared understanding among them. As Keith and Fraze explain, error management training is a training method that takes an explicitly positive view of errors during training, explicitly encouraging participants to make errors during training and to learn from them. The reason we decided to not include this variable in our model is that the variables we have used are concepts, while error management training is a specific method. It therefore did not fit well within our model from a conceptual perspective. To get a better understanding of our model and be able to formulate implications, we have classified our variables as either stable or malleable. To do that, we have applied the 24-hour rule. If a variable can change within a time span of 24 hours, it is characterized as malleable. If not, it is stable. Based on this, we have come to the following conclusions. Effective communication, psychological safety, and learning from errors are stable variables, as they cannot be changed within a 24-hour time frame. Building effective communication, psychological safety, and a learning from errors climate within an organization requires the implementation of appropriate strategies and, importantly, time. Groupthink, on the other hand, is a malleable variable, because with the appropriate interventions, it is possible to avoid this cognitive bias in less than 24 hours. As groupthink is a malleable variable, an implication that follows for organizations is that by intervening on this moderator, that is, taking measures to avoid groupthink, the likelihood of the organization making correct decisions increases. One intervention that could be implemented to avoid groupthink is to appoint a devil's advocate when group decisions need to be made. The devil's advocate will be responsible for purposely taking the opposite position from that of other group members. Studies among those carried out by Ahmed et al. Have found that appointing a devil's advocate can prevent groupthink, leading to a higher quality group decision. This is because the opinion expressed by the devil's advocate requires other members of the group to reflect on this and see the matter from a different perspective. Other interventions include training managers to recognize the signs of groupthink and take steps to tone down its effects, as well as to foster open discussions, encourage all voices to be heard, and handle competing viewpoints. Future research could investigate further matters related to possible interventions. For instance, it could look into whether certain strategies adopted by the devil's advocate are more effective in leading organizations to correct decisions than others. So, what have we learned from the Challenger Space Shuttle Disaster and our analysis? That making correct organizational decisions is crucial, and though it may be a difficult task at times, it is possible to maximize the likelihood of a correct decision by having the appropriate environment and attitudes within the organization.